Good morning, everyone. Myself Amrita D.S., Assistant Professor, Department of Civil Engineering, Hassan. So today we'll discuss about the distribution system. So water distribution system, in which the contents are the requirements of the good distribution system, distribution network, and the methods of distribution. These are the three concepts. Let me discuss now. So before going to that, what are the requirements of the good distribution system? So what are the requirements of good distribution systems? So one is it should be capable of supplying the water at the all intended places within the city with a reasonably sufficient pressure rate. So yes, this is a very much requirement for the good distribution system. That means it should able to provide a sufficient water with a sufficient pressure head. So that is required, and it should be capable of supplying the requisite amount of water for firefighting during needs. So the during the firefighting, so it should be capable of providing the water in an increased pressure head, and it should be cheap with the least capital construction cost. That is one more the requirement of the good distribution system. And it should be simple and easy to operate and repair. So here before going to discuss about the methods of the distribution system as well as the distribution networks, so these are all the requirements, that means are very much required for the system. And the other points which are included in are it should be safe against any future pollution of the water, and it should be safe as not to cause the failure of the pipelines by bursting, and it should be fairly watertight as to keep the losses due to leakage to the minimum. So these are all the requirements of the good distribution system. And let me move on to the layouts of the distribution networks. There are four different types of distribution networks. These are the majorly we are using the four types, in which the dead end system are the tree system, and the grid arranged system, ring system, as well as the radial system. So these are the major types of the distribution networks. And let me discuss about where it is suitable and what are the advantages and disadvantages of each system, each distribution networks. Whereas in a dead end system or a tree system, and it is very suitable in the places, that means if the city is a older city and if it is developed in a haphazard manner, in that particular situations, so this dead end system or the tree system is very much suitable. uh, I think you all are observing the diagram of the dead end system or the tree system, in which there is a main pipe, that is a center pipeline, that's a main pipe, in which there will be a four sub mains are connected to that main pipe, and as well as a lateral pipes, that means the lateral pipes is nothing but the shortest pipes which are connected and which is at the dead ends. That means, so it's a branch of tree, it looks like a branches of the tree, and it's having no loops or interconnections. That means this type of the layout is very suitable for the older towns, have said before that also. So and it is very much suitable for the older towns, and it's a dead end system, or we call it as a tree system. It's looked like a tree because the branches of the trees, there is no loop, there is no interconnections between the branches, and that is the dead end. Then if we choose this particular network system, so then what are all the advantages and disadvantages of this particular the system? Let me discuss. Okay, what are the advantages now? Accurately uh, and it is helps to calculate what accurate calculation of the pressure and discharges at different points in the system. So because in a dead end system there is no interconnections or there is no loop in this system, so this could have help for the calculation, accurate calculation of the pressure as well as the discharge at different points in the system. And also it requires a lesser number of cut-off valves, and it is simple and cost effective to design and construct, and the shortest pipelines or the pipe networks are required. As we said that there is no loop and there is no interconnection, and the shorter pipelines are required. That means it looks like a completely the tree system, in which a tree is the main, that is the stem is the main part, as well as the branches we call it as a it's a sub mains, and as well as the again there is a subdivision, we call it as laterals, we call it as, and that's why it requires a shorter pipeline. These are the advantages. And what are the disadvantages of this dead end system or a tree system? So the disadvantages are, what may be the disadvantages? That is, one thing is we need to discuss is because there is no loop or interconnection, there is no circulation of the water takes place. That means it leading to a potential quality degradation, and it's difficult to maintain the high pressure during the firefighting, and also the ease of, that is a, and also the maintenance and the repairs is very difficult. So it is a limited flexibility in case of maintenance or repairs. So these are the advantages and disadvantages. Let me discuss once again. The advantages are, accurately we can measure the pressure as well as the discharge, and also lesser number of cut-off valves are required, and simple and cost effective to design and construct, and require shorter pipelines. And as well as the disadvantages, because it is a dead end system, so there is a possibility of degradation takes place. That means it's leading to a potential quality degradation, and it's difficult to maintain the high pressure during the firefighting, and also the maintenance and the repairs is also difficult. These are the disadvantages of dead end system or tree system. Let me move on to the further, that is the next network system is gridiron system, in which, so look, I think the figure will give the clarity of that. That is a main, that is a central, the line, that is a dark line indicates that it is a main pipe, and as well as the B, that means that the horizontal lines, what we call it as a branches, and the S we call it as a submains, and dot, that is the dot which indicates a cut-off valves. Okay. Whereas in a gridiron system, and it looks like a grid pattern, that means there is a formation of the loops, there is a interconnection between the one pipeline to the another pipeline, and this ensures the multiple supply paths to every path in the system, and it is ideal the large and the planned urban areas with a high population density. It's very suitable, and also one of the example, it has been used in a Chandigarh. So the gridiron system and as well as the ring systems are very suitable for the planned areas, planned urban areas. Whereas if the situation is if the city which is developed in a haphazard manner, so which system of the network is suitable? So obviously it is a tree system or a dead end system. Whereas the gridiron system, it is very suitable to the area which is well planned. That means a planned urban areas with a high population density, and this system is very suitable, and it has been used in Chandigarh. We can say the example of Chandigarh. In Chandigarh, so we have followed the pattern of the gridiron system, in which the water which is supplied through this system of the network. And let me discuss about the advantages and disadvantages. Okay. So then what are the advantages? So one is there is a uniform pressure throughout the network. Yes, obviously, because there is an interconnection between the pipe to pipe. And a continuous water supply, yes, even during the pipe repairs, if one side of the pipe get repaired and the other, we can get the water from the other pipe. So that means as water can be routed through alternate loops, yes, we have the alternate ways to get the water. If one pipe is get repaired, and we can get the water to the another pipe. So that is one more the advantage. And the improved water quality due to reduced stagnation. Yes, water gets circulated throughout the loop. So then there is a circulation of the water. So that reduces the stagnation of water. And during fire also, the more water can be diverted towards the affected point. So that is a one more major advantage in a grid iron system. Whereas in a dead system, it's difficult to divert the water towards the firefighting. So that is a one disadvantage in the dead end system. Whereas in a grid iron system, we can easily divert the high pressure water where the affected where the place which is affected by a firefighting. And what are the disadvantages? This system requires the more length of pipelines, as obviously we are connecting the pipe to pipe. That means the interconnections between the pipe to pipe as well as the loop we are forming, and that's why we require the length of that is a more length of pipelines. And a larger number of sluice valves, because we are interconnecting, so we require the number of valves, that is the sluice valves. And as well as if you are connecting the pipe to pipe, the length of the pipeline is also increases. That increases the cost of the pipe, and that's why the higher initial cost due to additional pipelines and complexity, because we are providing the number of sluice valves. And it also requires the skilled design and installation. So these are the what the advantages and disadvantages of grid iron system. Advantages are uniform pressure throughout the distribution network, continuous supply of the water through that loops, and if one pipe get repaired, we can get the water to the alternate loops, and improved water quality due to reduced stagnation. And during the firefighting, we can provide or divert the high pressure water with a high pressure. And the disadvantages are, so its initial cost is very much high, and this requires the larger length of pipelines as well as the skilled labors are required for the design and as well as the installation. Let me move on to the next system, that is a ring system, in which the distribution mains form a closed ring. So here, so whereas in a grid iron system, the center part is the main pipeline, whereas in a ring system, the distribution means the main pipe forming the closed ring around the supply area. So that means the borderline, so what we call it as the surrounding area, which are the distribution main pipes, and in which the branches which are connecting with the branches leading to consumers. And it is very suitable for the towns and cities having a well planned roads. So if the city which is having a well planned roads, in that particular situations we can use the ring system. And the ring system in which the main pipes which are forming a loop are a closed ring around the supply area. That is the difference between the grid iron system as to the ring system. Let me discuss what are the advantages and disadvantages. Here, the advantages and disadvantages are similar, most of that is similar to the grid iron system, because here also there is an interconnection between the pipe to pipe, and that means it forms a loop. So same advantages and disadvantages when it is compared to the what that is the grid iron system. The grid iron system and the ring systems are almost the same, and the advantages and disadvantages are almost same. So the example, that is ensures consistent water pressure at the advantages, and allows suctional isolation for repairs without disturbing. That's it is the same advantage. And water flows in a multiple directions preventing stagnation. Yes, same advantage. And the disadvantages, that is a higher cost due to additional means and complexity. Yes. So next we'll move on to the radial system. Next we'll move on to the radial system. So in which the radial system, whatever the dotted line indicates the distribution reservoirs. So I think here in the figure we are seeing the four dotted lines. That is the four. That is the dark balls we have, black dark balls. So in which the water which is discharging radially, that means the radially the water which is flowing to outwards to the consumers, and in which the entire area is divided into number of zones. For example, if we, because we are living in a Hassan city, so we are dividing the Hassan city into number of zones. For example, if you take the north, south, east, west as a four zones, we can divide it, and each zone is supplied from a central reservoir through separate pipelines. So that means, for example, if you take a Chanpatna circle as well as in a Dairy circle, so like that there is a north, the south, the east, west. We are separated into four different zones, and each separate zone we have a separate central reservoirs, and through that the separate pipelines we are providing, and radially the water which is flowing to the consumers. This method ensures the high pressure and efficient water distribution. And let me discuss about what are the advantages and disadvantages. The advantages are it's highly efficient in terms of pressure control and distribution, yes, and easier to manage and monitor supply in the specific zones. And what are the disadvantages means it requires multiple reservoirs and pumping stations, and that increases the cost. Yes, obviously, because for example, the Hassan city is having the four zones. In each zone, we required a separate reservoirs for supplying the water to the each zone. So that obviously requires the different pumping stations, as well as the that increases the cost of the system, the radial system. And it is highly efficient. Yes, we can agree that in terms of pressure control and distributions, because for a Hassan city, if you have separated the four zones, means if a reservoir which is with a full the quantity of the water, that means obviously its pressure is pressure control, that is means highly efficient in terms of the pressure control and distribution, and easier to manage and monitor supply in the specific zones is obviously. So that increases the cost of the system. And let me discuss about the methods of distribution systems. There are three common types of distribution methods. So what we have discussed previous, those are what distribution networks. That means how we are getting the water from the storage tank to the consumers, how we are supplying, through what through these pipe networks. So the dead end system or tree system, gridiron system, ring system, and radial system. Whereas in the next is methods of distribution. The what are the methods, in what ways the distribution systems? There are three common types of distribution methods. For example, there are three types of distribution methods. That is, one is a gravitational system, pumping system, and the combined gravity and pumping systems. These are the three common types of distribution methods. So let me discuss one by one. Okay, gravitational system. Water flows from a higher elevation. That means the reservoir, when the reservoir which is located on a hill station, so that can easily distribute the water from higher elevation to the lower elevation to the distribution area due to gravitational force, and no pumping is required in this system, and suitable for cities and towns located at the base of hills or for areas with natural elevation difference. So gravitation, it is a simple. So if the storage or a reservoir which is at a higher elevation, when the city or town which is at the lower elevation, we can easily draw the water from the higher elevation to the lower elevation by the gravitational force. And what are the advantages and disadvantages of this gravitational system? The one the advantages: energy efficient and low operating cost, as no pumps are required. And obviously it is what, it's a what economical way of economical method of distribution system, because the water, what we are drawing the water from the source without pumping, that means no money is required for that. So that means energy efficient and low operating cost, as no pumps are required, and simple and reliable design. Yes, and uniform pressure distribution in the most cases. These are the advantages. And disadvantages are: initial construction cost is high if an elevated reservoir is not naturally available, and difficult to implement in flat terrains. So yes, obviously in flat terrains it is difficult, and the initial construction cost is high if an elevated reservoir is not naturally available. That means if the if the reservoir is not naturally occurring, so we have to construct the elevated the storage or the reservoir at the higher elevation, so that requires a more cost. So that's why the initial construction cost is high if an elevated reservoir is not naturally available, and it's difficult to implement in a flat terrains. And let me move on to the pumping system. So we know that the pumping system, if the reservoir or the storage tank which is at a lower elevation, and if the city or the town or a village at the higher elevation, so we have to lift the water from the lower to the higher elevation, it requires that the pumping cost. And so commonly it is used in smaller towns or the areas with stable electricity supply, and it is water which is directly pumped into a distribution network without intermediate storage. So here no intermediate storage are required, and we can directly pump to the consumers. And it is suitable for flat terrains or the areas with a limited elevation difference. Yes, within a short or a limited elevation difference, we can use or pump the water from lower elevation to the higher, and used when storage reservoirs are unavailable or impractical, when the area or the situation which is not capable of that means in a particular area or situation it's not able to construct the storage reservoir. In that particular places we can directly go for the system of, that is a pumping system. And this is the diagram which shows that is the raw water from a lower leveled source, and the lift developed by a pump, and the main demand, maximum demand, and the starting gate, and with the treatment plant. So after the treatment only we are distributing the water through these methods of distribution systems. And what are the advantages and disadvantages of the pumping system? So advantages of this pumping system are: lower initial construction cost when it is compared to gravitation system. Initial construction is very less when it is compared to gravity, and whereas and the maintenance cost is more, and provides flexibility in pressure control. And the disadvantage is operational maintenance cost are high when it is compared to the gravitational system. And water supply disruption during the power failures or pump breakdowns. So here water supply disruptions are during the power, if the power cut off, so in that cases will cause the disruption in the water supply. These are some of the disadvantages and the advantages of the pumping system. Let me move on to the last system, that is a combined gravity and the pumping system, in which in this case water is first pumped into a elevated storage reservoir, that means over a tank. For example, in a Hassan city, in a Jainagara, we have over a tank. So first we have lift the water from the source or the reservoir to the overhead tank, and distributed by the gravity to the network. That means whatever the initial construction cost, if we are artificially we have to prepare a overhead tank, or we have to construct a overhead tank, that requires the initial investment. And after constructing that, we are drawing the water through the network systems. For example, the dead end system, and the dead end systems, the gridiron system, or the tree system, as well as the ring system and radial systems. So and through how we are getting by gravity to the network through the gravitational system. That means here the both combined gravity and pumping systems are required. That means the gravity after overhead tank we are drawing the water due to gravitational force, whereas the to pump the water from the lower resource to the higher elevation reservoir or the overhead tank, that is artificially constructed overhead tank, so that requires pumping. Then after the overhead tank, so if we draw the water from the overhead tanks through the gravity we are getting, so it's a combined gravity and the pumping system. In most of the cities, for example including the Hassan city, we are using the combined gravity and the pumping system. And during peak demand, pumps can directly supplement the supply. That is, during the peak hours or the peak demand, pumps can directly supplement the supply, and ideal for areas where the source is at a lower elevation and uninterrupted supply is critical. And it's widely used in urban and semi-urban areas with varying topographies. If there is a difference in the elevations to the downwards downstream to the upstream, so in that particular cases we are using a combined gravity and pumping system. And this is a figure shows, so maximum, that is a overhead tank, so whatever the bell shape the tank which shows the overhead tank, and from over that we are drawing the water through the pipelines, so that elevated distribution reservoir to the consumer's level. So this is a combined gravity and pumping system diagram. And finally we'll discuss about the advantages and disadvantages of combined gravity and pumping system. Advantages are ensures a steady and reliable water supply even during the power outages, as reservoir act as a buffer. During that periods, that means the reservoir act as a buffer, so during that the steady and reliable water supply even during the power outages, so in that cases it's providing the consistent water supply, and combines the benefits of gravity and pumping. Yes, it includes both, and reduces pumping cost during the off peak hours. So these are the advantages, and disadvantages are higher initial cost due to the need for pumps and reservoirs, and it requires skilled operation and maintenance. So in this particular this presentation I have uh, delivered the talk which is on completely, which deals with the water distribution systems, in which have covered the three major concepts. That is, the one is the what are the requirements of the good distribution system, and secondly the types of distribution networks, and the finally the methods of distribution system. So requirements of the good distribution system, and the next is the types of the common types of the distribution networks are that through which that networks, the redundant system are tree system, gridiron system, ring system and radial system. And the distribution methods are the pumping system, gravity system, and a combined pumping and gravity system. So thank you students.